Hello everyone. Hello, hello, hello. Okay. Can you guys hear me okay? Have I done everything right? I think I have. How exciting. Hello Hayden. Hello Alex. Give it a few minutes. Elaine? Sorry, this text is a bit small. I need to make it a bit bigger. Hey Brendan. Hey Tom. How's everyone going? Cool. Alrighty. Hayden. Oh my god, Hayden. Yeah, I agree. Um, let's get straight into it. I'm really excited for today's topics. The first topic I think is going to be super useful for you. And really, it's one of these topics where you've probably come across, in the project or just working with Git yourself, situations where you've come across these sort of problems and you've maybe not known how to solve them, or you've figured out how to solve them. But really, I'm really excited just to have a discussion about resetting and amending and working with Git a little bit more advanced than we've covered so far. Because really, when you're out in industry or using Git for research or for anything that you do, it's a really powerful tool. There's a lot of different things that you might need to know for small circumstances. So I'm really excited to have the chance to talk about some of the big ones that will really help. And then even some time to just have a chat and share some tips and tricks and things that I personally do and I employ when I use Git. And maybe even some of you can contribute some of your ideas and some of the things that you do if you've used Git many times in the past. And if Hayden's still around, we can also get some ideas from him as well on what he thinks is helpful. So really, let's get into the slides. Oh, before I do that, actually, hopefully everyone saw my announcement about the classes on Friday. It's not ideal. It really sort of sucks, but it's not possible to reschedule the Friday tutorials into other days of the week. And so hopefully the announcement was clear. If it's not clear, let me know in the chat and we can have a quick chat about it. But if you do have a tutorial on Friday, the short of it is that there's no classes on campus or online whatsoever on Friday because it's a public holiday, it's Good Friday, Happy Easter, all of that. But so what that means is we're going to make the tutorial recorded and available online for you to watch and follow along. You could do it on Friday or some other day, whatever it is you want to do. Some of the tutorials on Friday will run as an online sort of help session hybrid tutorial thing for the people that would have been in that class anyway. And so you could potentially still attend to maybe a shorter class or something like that. But that really does depend on the tutor's availability. It is a public holiday. And there'll be no attendance or participation marks recorded for Friday students, so they'll just get the marks. But if your tutorial lab isn't on a Friday, then nothing changes for you. Everything's the same. And we'll probably add an extra help session or two just to compensate, right? I'll just post an announcement with the recording, Elaine. Cool. Got any queries about that? Feel free to email me, or you know what? Actually, I take that back. Email your tutor. They'll be the one that'll be able to help you the most if you've got a class on Friday. But I think they've already started emailing all of you to let you know what's going on. If your tutor will be in touch, our tutor. Yeah, okay. I must have put a typo in the in the announcement. Is it something I need to fix, or is it just a... Yeah, your tutor will be in touch to let you know. I think it's an editing thing with WebCMS that went wrong there. So you'll get notified by your tutor if you've got a Friday class and something will change there. Alrighty, so other than that, let's see. Yeah, I think that's fine. Okay. Obviously, we've also got the iteration 3 due soon, but I mean, again, you'll be used to all of that by now, and hopefully you've been working with your tutor on that. All right, so let's get into it. Okay, sorry, I've had a long day of meetings, so I need to shake out the boringness of it all. So sometimes we make mistakes when we use Git. I mean, this is not something that's going to be groundbreaking. It's always going to happen. It always will happen. And sometimes a mistake isn't even necessarily a mistake, it's just that things changed and the original plan is not going to be what you execute. And so Git has a number of features built into it to help you actually resolve what you've been doing and to get the best outcome. So there's a few things that we'll be touching on. So resetting, and we'll break down the different types of resetting concepts that Git utilizes. And resetting, also is related to altering the Git history. We'll talk about the Git history and what that means and what it means to edit it. And amending a commit. That one's a really actually helpful concept. And then there's some stuff that I just want to talk about that's not really included in the lecture slides. It's just things that I've picked up over the years that I think are really, really helpful at just elevating you a little bit better, a little bit more in your usage of Git and as a software engineer, and just to expose you to some cool tools that we use in the industry. So far, the typical workflow when you use Git, you're building on the Git history. So you do something, you stage the files using git add, you commit the files with a commit message, and you push the commit. And then you repeat that ad infinitum, and you end up with a chain of commits that forms the Git log. I'm really quiet. Is that better? Hello, hello. Let me see. Oh, I can put it way up. Is this better? This should be better. Hello? I'm in the red now. This is surely better. Was fine earlier? I don't know. Okay, cool. All right. Oh, my ears. It's too loud now. Okay, so maybe. Okay. All right, anyway, let's not spend any more time on it. Yeah, so typically what you've been doing, you've been making some commits, making some changes, committing, making a commit, and then doing some more work, committing that, doing some more work, committing that. And what you end up with is a chain or a log of commits. And we can view that with the git log command, right? So this is something that you've already been doing. But we haven't really spoken about, maybe you've already done this, but we haven't really spoken about how we can navigate that log and actually modify what's happened in that sequence. Now, the reason we need to do this is sometimes in one of those commits we actually make a mistake. We put something in it we weren't meant to, like a file, for example. Sometimes that's a really big deal because the file contains a secret or a password or a key that we don't actually ever want to be available in the history. Sometimes we just want to undo a change because we're not going to end up going down that path. And sometimes we actually want to change a history. So for example, if we do want to remove some particular file from the commit history. And there's two major ways we're going to talk about doing this, with resets and with amending commits. I think I might actually start with amending commits. I think it's the most straightforward. So I'm going to flip the order a bit. So git commit, amend. So basically, it's a really simple concept, and we'll just jump into it with the demo, and I think you'll really get it. There is a flag on the git commit command in Git called amend. So -- amend. And then you just give it a commit message as per usual. And what it basically does is jumps to the previous commit, sort of like reboots it, and lets you change what was happening in that commit message. So you can actually, I mostly use this when I make a typo in my commit message. So I'll add a few files, commit the file with a message, but I'll have a typo in the message. And I don't want to make a new commit because then I'll have duplicate commits with just a typo and then the fixed typo. Does that make sense? But what this does is replace the most recent commit with a new commit instead of adding another commit to the history. Makes sense. Let's just go into a demo with this. So I've got here just an empty directory. Let me get my terminal up here, called git test. Now this is not actually a git repository, right? So if I go git status, there's nothing here. So this is a completely empty, let's just make this a bit bigger. so you can all see it. Is that looking okay? This is a completely empty directory. So what I'll actually do is make a, oops, where did my browser go? Oh, this is my browser, of course. I might just make a repository in my personal GitHub. Now, so you would just be using GitLab at the moment, but I could have used GitLab, but I thought I use GitHub most of the time. It's the exact same thing. Why not just show you something slightly different? So this is my personal GitHub user, I guess. I'm going to make a repository. It's going to call it git1531 demo. Let's call it that. I'll make it public, that's fine. No template, that's fine. And I will create this repository. And then what I'm going to do is grab that URL, come over to, not this, come over to here, and I'll just git clone that repository. That's probably going to make a new directory. Yeah, and it's an empty repository, that's fine. Go in here, and now I've got another empty repository, but if I type git status now, you can see that we actually do have a repository, there's just nothing in it. Alrighty, again, if there's any questions with this so far, let me know at any point. I'm just gonna open this as its own sort of directory, so it's a bit clearer. Alright, get the terminal open. Now there's no file. So the first thing, let's just add a file, program .py, and let's just put, you know, some code in there. All right. So how do we, you know, you all know how to do this now, but we add the file, I make a commit, and I give it a message. So I'm just making my commit just as I usually would. And let's say what I wanted to do in this commit is to, you know, add initial program file. And I've made a typo in my commit message, right? So I've spelled file completely wrong. But I miss it, I write the commit, and then I go to look at the git log, okay? And I see, oh damn, I've made a typo in my commit message. Who has made a typo in their commit messages when they've been working on the project? Let's do a poll. We do a poll. I mean, Sienna's made 10,000 commit message typos. Look, the thing is, they're not the end of the world, right? They're not going to they're not going to bring your system down necessarily, but it depends the team, you know, that you're working on. When you're in a professional environment, you want your work to be professional. You want your Git history to be professional and to communicate the work that it's done. And especially if you're doing sort of open source contributions, you want it to all be fixed up. Yeah, so Stephen and Tom, I mean, you've just been burned and now you're proof checking. But even if you are careful, trust me, it'll be late at night one night, 2 a.m., you'll be exhausted, bloodshot eyes, and you'll make a typo in the commit history. So if I don't, let's say I don't know about amending the commit, I'm kind of screwed here. So I can make a new commit and fix the typo. But then if I ran git log again, there would be 2 commits, and now I'm clogging up the commit history, right? So the git commit amend feature allows us to go back to our previous commit and just modify it. So I can go git commit --amend. So what I actually do is just run that, and it brings up in my text editor that I've configured for Git, and we can talk a little bit about even that, for example. It brings up, if you see here, it's brought up, it's not an empty commit message, it's the previous commit message with that typo. And then what I can just do is come over here. Now this is using Vim because that's just the default text editor that my Git is configured for, but you can actually change what it's used for, and I'll show you how to do that. But I can just come in, whoops, if I'm in insert mode, fix that typo, So add initial program file, that's looking good. I escape insert mode, I write that, and I save that basically. And what we see here is that we get that commit made. Now, if I run git log, there's still only one commit. That's the most important thing. So we have our fixed commit message. Now, okay, let's pause there for a second. Are there any questions on just the most basic use of commit? I'm going to assume that that's not too bad. I can show the commit command again, absolutely no problem. Git commit -- amend. Now you can actually go -m and then provide the message. I just do that, and it just brings up in a text editor the previous commit. And I'm just going to exit out of this. Now, who was it? Stephen? It was Stephen twice. Yeah. Stephen's asked a really important question. Can you still amend after you pushed? And this is where we run into the problem. In this example here, I've been local, everything's been local. I didn't push the commit with the typo. So right now, why don't we just go git push and push to my repository that file that we created. And if we have a look, and I refresh here now, we'll have that file. And if I look at the commit history, and you can all do this the same as GitLab, you'll see that the only commit here in that log, let me just make this a bit bigger, is the one with the fixed commit name. Now, let's make another typo, but push it, and then see how we can fix that. So this is the wrong editor. Let's change this to print foo twice, okay? So I make a git commit -m, right? You guys have seen how to do this, and I say extend program printing, right? Okay, now I need to make a typo. Something like that, who knows? I gotta add a file first, of course, then I can commit that. All right. I look at the log, and we have our original commit, we have a new commit with a typo. I've not noticed it, but I push it. So I push that commit. I go over to my browser, and we see, damn it, I've pushed a problematic commit. My problematic commit is now available for the whole world to see. Now, how do I fix this? Here's the interesting part now. Here's where it gets interesting. How do I amend the most previous commit? We know how to do that. Nothing changes. I run git commit amend, and we get up the previous problematic commit message. I go to insert mode, I fix it, I save that. And now if I look at my local commit log, let me just run that again. I can see commit number 1, all good. Commit number 2, all good because I committed it. So then I think, okay, look, I'm fantastic. I'm the best programmer alive. Nothing can stop me. I'm gonna rebuild Linux from scratch and dethrone Linus Torvalds. So I push it. And then it's like, oh God, a red line when I ran a git command. I'm the worst programmer ever. I need to quit, and I just want to never see a computer again. Yep, that's basically what happens. So what went wrong here? And if we go back to the browser and we go to the Git repo, you can see here that my problematic commit lives on, besmirching my good name for all eternity, mocking me and laughing at me, even though I fixed the commit. Everyone's going to look at it and laugh. So this is the point either where you delete your repo and kill the project, or we think about how we can fix it. So what's the issue here? The issue here now is that the local commit history and the remote commit history have diverged. I've made a different commit basically locally. And it's telling us right here, the updates were rejected because the tip of your current branch is behind its remote counterpart. And that they're not integrated. So the commit on the remote repository and the commit that I have locally aren't aligned, and Git doesn't know how to consolidate that. Now, in this specific circumstance, if we think about what we have locally and what we have remotely, can you guys tell me which is the copy of the remote that we actually want? Is it the one on the repo, on the remote server, or is it the one we have locally? Which is what we actually want? I'll give it one more second. I mean, it's not a tricky question. If I look at the log here, this log has no typos. This log has typos. I want the local log. So one thing I can do here is actually force push the repository. And basically what I'm saying is, look, I know that our commits differ between the remote and the local repository, but actually I know and I'm confident that what I have locally is what I actually want. So I can just run git push --force, and that will just override the head commit of the repository. And then we can see here, we have our initial program file, and then we've got our resolved extend program printing. And if we look at that commit, you can see that it is the commit, it contains the changes that we actually wanted to make in that position. It was made 4 minutes ago, and it resolves the typo. So this is I do this all the time. I make a typo, I push the commit, I go, damn, I've already pushed it, now I can't push it, so I'll do a force push. You've always got to be careful with force pushes. We'll talk a bit about it in a second, but for just amending the commit name, a force push is likely going to be just fine. Cool? There are actually other ways you could solve it, I think, but this is a really common one. So maybe it'd be worth just coming up with some, you know what we can do actually? So just some git, let's make a little file here and call it git tips.markdown. And then let's actually just build this. Actually, this can be what we commit. That'd be pretty cool. So amending a git commit because you made a typo. So you can run git commit -m problematic commit message. Then you can just go git commit --amend. And edit the message git push or git push force if you pushed the problematic commit and nothing else afterwards. Cool. Now, if you actually continue to commit, that's a different situation. And there's ways, I think, to edit a specific commit message previously, but we'll take a look at that a bit later, I think, if we get to it. Another little sort of tip, I think this is just going to become a ramble of Git tips. Are we all happy with that? Because I'm coming up with things as I talk, and so the order might be a bit messy, and I'll do my best maybe with the time bidding on YouTube or something. We happy to do that, just to have sort of a free flow of these ideas? So you'll notice when I committed, when I amended the commit, I just used git commit amend and used the internal Git editor. Git change editor config. Whoops. This is the flag. This is the command to actually edit. Here we go. We're going to have like nested edits here. This is the command you can use to actually edit the text editor that Git launches when it doesn't have like a message that's given to it. So if Git ever needs something to be edited by the user, this, for example, will switch it to use a nano, but I think you can actually tell it to use, like for example, you could tell it to use VS Code. I don't really want to do it because, screw it, I'll do it. Okay. Oh no, not, what? Oh, here we go. Okay, that doesn't work. This might be old. Editor. Is it like this? There we go. Now if I go git commit amend, do you see that? So it actually brought up that commit editor in code, and then I can edit the commit. That would make it more problematic. And then I can just save it, I think. Is that all I'll do? And then if I git log, I don't actually know. Oh, do I just close it and then it works? No? Let's give it a quick. Use VS Code as Git editor and save. Code wait. Sam, you know, are you not a 1531 student? That's quite funny. Let's try it. Does that not work as well? Okay, git commit amend. Waiting for your editor to close the file. Yeah, cool. I've never actually done this. I close the file, and then, oh, that looks like it worked. And then if I view the log, okay, that's really cool. There you go. I don't know. I'll go back to using Vim probably because then it works in like other terminals and things. But if you're, if you're really comfortable in using code and you're working in code all the time and you just want to edit the commits there, it's not a bad way of doing it. So amending a commit may bring up an editor. You can change this. And then that's one option, or you could just do, for example, nano. Nothing wrong with that either. Cool. Yeah, welcome to 1531 Sam. I hope to see your 3 iterations due on Tuesday next week or something, and good luck for the exam. Okay. Let's see here. So another thing you might want to do with amending, I suppose, is amending a commit that wasn't the most previous commit. And I'm going to actually have to Google this one because it's been a little while. So git commit previous commit, oh, not commit, git amend previous commit, not most recent. Let's see if that comes up with something. How to modify specific commit, excellent. Okay, I don't want to really talk about rebasing. Is there no easy way to do it? Okay, don't be afraid to rebase. That's the funniest thing that's ever happened on a lecture stream. Okay, I'm not going to go into this demo, but basically if you make a commit message problem before the most recent commit, you're a little bit more screwed. Basically, you need the reason for it is that the future commits will refer back to the problematic commit, so you need to like go back to it and like modify them all sort of to point back to the previous one. You can just look at something like this if that comes up. Yeah, so Muhammad, yeah, you're right, and we have that in the slide here. So you don't need to use the text editor in launched by Git to modify the commit message. You can just provide it a new commit message. But sometimes you have commit message bodies, and you do actually need to use the amend with the editor. Does that make sense, Mohammed? Cool. Alrighty, let's go now and talk about Git resetting. So, what's Git resetting about? So, Git resetting is when you basically want to go back to a previous commit and to either maybe continue working from there or to get rid of the changes between that commit and the current commit. There's a variety of examples for when you may need to actually do a Git reset, and there's a few different ways we can do a reset. So like always, Atlassian has a pretty good article on Git resetting. We're not going to go into the details of the actual article too heavily. We'll just probably do some demos, but you can have a look at that article if you need to. So let's look at hard first, because I actually think it's the most simple to understand. So let's say we go back to our editor here. Now, actually, if I go git log. Okay, well, this is a good example, right? So let's say I've got this this commit here. I actually don't want it at all. The commit might have added a file that I never wanted to be included in my repository. In fact, let's say this git tips file here, I accidentally go git add dot, which is to say add all the local files into as staged, and then I git commit add file I never wanted to commit. Now if I push this, and I have to force push it because I made a git commit amend, and now I go, oh damn, if we go to our git repository, which is here, I say, oh damn, I never meant to push this file. I never wanted it pushed. I want it gone. What do I do? And the problem here is, so what we could do, right, is we could remove the file, right? We could delete the file, make a commit, so add it, commit it, and push it, right? The problem would be that this commit would still exist with the file in the repo. Does that make sense? Do you need me to? Do you want to see me do that just to prove what I'm talking about, or are you happy? Do you have that sort of locked and loaded in your minds? So I could delete the file, make a new commit, and push it. But the problem with it would be that the file would still exist in this commit because I didn't get rid of this commit. I could amend the commit, but that's just going to change the name of the message. The file contents would still be here. So that's the problem. So what can we do to actually remove this entire commit? And the solution is a git reset. And I've lost the slides. A git reset. So sets all of your code back to a specific commit. So this is used in the situation where you say, I want to go back in time and I don't care about anything that's happened since the point I'm going back to. So you will actually lose, and you got to be really careful with these commands. You will lose anything that you've done in between your current commit and the commit that you're resetting to, assuming then that you then push it. Does that make sense? So Michael, we don't want to make a new repo. We might have a long history here. So what do? So we run git log. Git log is our best friend. And we see, here is this commit that adds the file we never wanted to add. Here is the commit that is, I'm happy. This is where I want to be, right? I want to be back down here. I wish I never did this. It's making me miserable. I don't want to be here. Okay, we don't like that. So we want to go back to this point. So we copy this git commit hash. So we're copying the hash of the commit that we want to go back to. And then we can just run git reset -- hard, and then we just paste that commit hash into the command. And what it will do is really simply jump to that specific commit. If I run git log now, let me just clear it so it's easy to see, I only have 2 commits. It's gone. And if you look here, even my VS Code editor is telling me that that file is gone. In fact, the file is deleted. Now I've copied it because I'll bring it back later. The file has been removed from the directory. I've gone back in time. I mean, it's kind of cool. I've literally gone back in time to a previous commit, and I've reloaded the directory to look like it did when I made this commit. And at this point of time, which was 2:22, 58 seconds past the minute, there was no file with those instructions that was committed. Okay? Now, same sort of issue though. If I go back to the repo, this commit is still here, right? I haven't pushed. The remote repository has no idea that I did that reset. So what do I have to do here? How do I sync up my local repository and the state of my local repository with the remote repository? Any ideas? Yeah, exactly. Default. I push it. That's how we always do it. We just push it. We have local changes we want to push to the server. We push, git push. Now, is that going to work? No. Well, sort of. The same issues happened like when we had the amend situation. The remote repository, it doesn't sync up. It doesn't know, it doesn't understand how can there be a commit that comes from the future that wasn't, that isn't here. They're not synced up. But again, we know, okay, I've actually gone back and rewritten history. I've reset the repository. And because I've done that, we will need to do a force push in this example. Now the force push, what it's really there to do is to protect you from accidentally deleting something that you weren't meant to do. In this case, we know we want to do this. So I can do a git push force, and it will override the remote repository with the state of my local repository. And then the really cool thing is here that if I refresh here, that commit is gone. That file is gone. And if I go back through all the commit history, that file is never in the history. So if there was something sensitive in that file, it was sort of never saved. And this would all work the same with GitLab, GitHub, whatever. And so we've gone back in time. We've eradicated a commit that had a problematic file in it. We've reset to a previous commit, and then we've pushed that up with force, because we need to override the remote repository to gut out that bad commit. And we're happy. Does that make sense? Now I can, why don't we add the file back, git tips, and I can paste that in, no problem. I can git add it. Actually, this brings up another tip. Now this is a case where, trust me, do as I say, not as I do. You should never, you want to avoid doing git add and then everything. The reason for it, if we do this, is we will often stage files that we don't mean to. So I might forget that I dragged a file in. I might accidentally have put a folder there. If we add everything, everything will be added. Most of the time it might be okay, but oftentimes we will actually stage things we never intended. It is better to just go git add git tips.md. And even if you have to do that a few times, it is the safe thing to do. I will absolutely throw my hands up and say I almost never do that. I just, unless I really unless I want to add. What I'm saying is sometimes when you've only got one file to commit, it's still safer just to use only that file name. Try and avoid adding wildcards, too many wildcards. And then I can go git push, git commit, add tips back, and then I can push that, and that's fine. Okay, Sam asks, isn't Sam the student that's not our student? I don't know. If someone else has pulled from you, you're going to pay student fees, Sam. If someone else has pulled before you force push and then they pull the force push, will it delete the commit for them as well? Great question. The answer is yes. Look, if someone pulls before, so after you make the problem, and then before you fix the problem, you are kind of screwed. What will likely happen is they'll message you on your internal messaging tool like Slack or Teams or something and be like, what is going on here? I'm not able to pull, I need to, and then basically you'll have to negotiate with them how to fix it up. It's just something that happens sometimes. Okay, is there a method to add git dot except for some files? That's a great question, Default, and a great answer, Stephen, and something we actually haven't spoken about in terms of so gitignore files. So has anyone heard of a gitignore file? They're super, super useful. Why don't I do this? Let's see. So a gitignore file is really, really important in large projects. Let's see. All right, my computer is fairly slow. So this is a repository for the application that I work on. Look at all the files. Yeah. Now, okay, this is the node modules file. We don't care about that. Okay, here's a gitignore file. A gitignore file is a plain text file that literally lists what files should always be ignored by Git in this directory. Okay, so it always sits in the root of the project, and it literally lists, so for example, don't ever add an Angular cache to the Git repository. Don't ever add a service, that's a service worker file. Don't ever add the logs. Don't add dstore files. I hate dstore files. I wish macOS could somehow fix that up. Don't ever add the build. Don't ever add the dist directory. This is like an entire directory. This is a particular file. So it's just a long list of specific files and folders that will never be committed if you run git commit dash, dot for everything. It's really, really useful. And then an even more useful thing. So there's a website called gitignore.io. I really love this website. I've been using it for years and years and years. You literally come along and you say, okay, I'm going to be working on a Python application on Mac OS. I'm going to be using Flask. And I don't know. There's also an Angular application in the directory. So you just give it some of the things that you'll be using, and then you hit create, and it will generate for you predefined gitignore files. So you just copy this and put it in to your gitignore file, and it will ignore all of the things that people over time have determined should not be in the Git repositories or don't need to be in the Git repositories for these environments, these frameworks, these languages, whatever it is. So gitignore.io, awesome website. So the reason why we have something like this is because you'll be building stuff And then you'll be like, oh, I want to ignore this, I want to ignore this, I want to ignore this. And it's actually sort of common stuff that, you know, if you're building a Flask server, everyone's always sort of ignoring it. So gitignore is just collecting these for you so that you can just generate them. So gitignore.io, awesome website. How about I put it in this file. Yeah, so Mohammed, you can absolutely add PyCache to your project's gitignore, and you can absolutely come along to here, get rid of Angular, because you're not going to do that. So Flask, Python, I don't know what Python vanilla is, Python, and you can go ahead and pretty safely use this, and you'll see here that PyCache is here. So, you know, turns out most people don't want to stage and commit the PyCache to the Git repository. So you can use this file. So that's gitignores. Okay. You can even have global gitignore files that sit in the root of your computer's operating system and apply it to every Git directory, but that's getting a bit more advanced. Okay. Okay, we also have soft resets. Soft resets are a lot less scary. So let's read the description here. They keep all of your current code the same, but just change which commit you're pointing to. So this is like saying I like the code that I've got, I don't want to get rid of it, and I don't want to change anything, but I just want to alter the history of commits that got me here. Okay, let's see here. So, all right, let's just do a demo. Just trying to see if they had any nice examples of how to sort of build it up, but let's just go wrong thing. All right, so I've added this file here. No, let me save the file. So here's an example. I think this works. Let me think this through for a second. I think this is fine. So if we have a look, we've added this. Let's just so we've added this gitignore.io thing to our file. If I run git status, you can see that there's a modified file. In this situation, here's where you might want to use reset. Do we want this change? Yes, we want the change. We want to include this note. But let's assume that actually it should have been in this commit. It should have been in this commit. When I added the tips back, it should have been there. I don't want a new commit with this change in it. So I want the change, I like the change, I don't want to reset hard and lose everything and go back to this stage and then have to re-add it and then I'm still screwed. I want to go back to this stage, but I want to keep this change. So I think what we do here, whoops, let me just delete this now so I stop going to it. All right, I think that's fine. I think I add it. I just can't remember if I add it first or not. I don't think so. Okay. For some reason, I don't ever use git reset soft as often as I use git reset hard. So that's interesting. I just don't mind, adding new commits, I guess. But we'll copy this. No, that's the head that we're at. So let's copy this. Let's try this. Git reset soft, and I'll give it the previous commit. If I run git status, okay, this looks good. We have two stages here. We have so it turns out I probably didn't need to add it, but it's going to be fine anyway. So we've got the addition of the entire file and we have the addition of the line, both staged separately. So if we view the git log, we don't have that we added the commit, that we added the git tips back. So what I can do here now is go git add, git tips, git commit. Whoops, oh yeah, I need to give it a message. Let me, I'll just do it here. Add git tips back. So I'm making a new commit here. I save that, I close that, and then I get a commit here that added the tips back in a single commit. If I view the log, I'm in the log now, you can see that that's worked just fine. I'll have to do another hard push because I've gone back and edited, whoops, not hard, force. I've gone back and edited the previous commit, and that's worked just fine. And what we will see when we go back to the repository will be a single commit with all of the changes, including the gitignore.io addition, in a single commit. So again, I've rewritten history, but I kept the changes that I made in between the two commits. I hope that made a bit of sense, right? So git reset hard would have just thrown everything away. Git reset soft kept what I had changed, but let me bring it back to one of those previous commits. And that is all the content in this lecture. Now, let's do questions. If you have any questions, feel free to ask them. And then I was going to show you one last thing that I use. I've lost it. Excellent. Or is it? No, it's here. Okay, so this is my git aliases file. So what I actually do when so sometimes if you notice I'm a bit slow when maybe I'm doing stuff with Git, it's because I'm trying to remember not to use my Git aliases. So I basically, over some years, have built up a series of bash aliases that I associate with Git commands. So for example, to run Git, I can just run G. I use GST all the time. So instead of running git status, I just go GST and I get the exact same thing. It's just an alias, right? It's an alias to, the left is alias to the command. But some of these are really sort of useful. For example, gg push is one I use all the time. And the reason for it is, have you ever made a new branch and then you go to push it and it's like you've got to set the remote upstream branch? This actually sort of does it for you. So you never have to think about it. You just run gg push and you always push it to the origin remote automatically. So I can make these all available if you want to check these out. These come from, I didn't come up with these aliases, not all of them at least. Some of these come from the ZSH git alias list. Yeah, OMO ZSH. A lot of these come from here. And there's a lot of useful ones here. I've just kept the ones that I use. And I think someone in the chat posted, like the git log graph online decorate. So what you could do is have an alias. I can actually go glgg. Oops. If I save that, come back to here, make a new terminal. Oops. And you get, I run glgg and I get this nicer, more condensed git log history command. So the aliases are kind of useful. Steven says, wait, what if you want to go like 5 commits back? Yeah, if you want to go, so basically, Steven, if you want to go, you can go back 5 commits. I can reset back to this commit. The problem is I will lose this commit and I will lose this commit. If you want to keep them, you need to rebase. If you're happy to lose them all, you can go and keep the changes. You can go with a soft reset. If you just want to lose it all and throw everything away, you can go through a hard reset. Does that make sense? CNSS helps with typos. Are you talking about the aliases there, or what are you talking about? Yeah. Where do we store this file if we are using SSHFS? Great question, Julia. You would store it on the remote machine. Yeah. Add this file to the repo. Okay, no problem. Well, you can, or do you just, because I think this is a repo. Maybe it's not. Because I also love z.sh. I don't know if you've ever seen me do this. So if I have a terminal here, and so let's say I want to change directories to my desktop, right? So I'd have to go like what, CD, maybe I have to go up a bunch of times, or I'd have to go like straight down to the desktop. What z.sh does is always listening every time you change directories, and it picks up your common directories. So I can just go z desktop, and it knows that, okay, desktop is a directory that I often change my directory into, so it'll just go to it. And then if I want to go back to Doubtfire, right, which is a project in a really nested list of directories, like it knows Doubtfire Web is my most common Doubtfire directory, and it will change my directory straight to there. And you don't configure it; it just watches and listens. It's awesome. It's part of ZSH or OMI-ZSH, but I don't use OMI-ZSH anymore, so I just took it out myself. So if you want this, you can. I mean, I think it's actually a. I think it's here somewhere in my repositories. I don't know if it's public or private. Here we go, public.files. Is it in here? It doesn't, this looks different. This looks like the old one I had. What do I guess I can just give you. I'll just give you all of it, I suppose. I'm sure there was a faster way to do this. Cool, there they are there. Git add that, git, I can go git commit with a message, add some of Jake's tools. Oh, never mind. That looks fine, and then I can just push that with gtpush. Cool. Yeah, I'm training my terminal. That's a nice way of putting it. Yeah, I think that's it for the stuff I wanted to talk about. All right, let's have a break, and then when we come back, we're talking about a completely different topic, but it's the classes bonus lecture from, it was going to be last week, I think, but it's sort of optional, and if we had time to get to it, and I think there's a bit of time today. So anyway, go over a break, get some water. I'm going to get some water, and I'll see you in 5 to 10 minutes, and we'll keep going today's lecture. Cool. Okay, welcome back. So how was that half of the lecture? Good? I really need like the chat. I need like a streaming expert to come and just like do my whole setup up. I don't know. I want like the chat like here so I can read the chat, but the chat's like off to the side. It's really annoying. Anyway, okay, welcome to now a really strange lecture. Oh, ignore that 8.3. We're doing this now in 9.4. Welcome to a kind of strange lecture. So let me set the scene for this. So, I mean, can you guys hear me okay? It should be okay. Looks fine. Let me set the scene a bit. Python is a semi-object-oriented language. And in using Python, you have come across, we've spoken about objects. You've used objects a lot. You can't avoid it in Python. Everything's an object, right? So you've used objects, but we haven't really spoken about how does a programmer, how does the Python team build the definitions of objects? How do you create your own object types, right? And that's what classes are. Now, object-oriented programming is a paradigm of programming, and there are dedicated courses to object-oriented programming. In fact, there is, I think it's 1521, right? That many of you will or can take. A course designed to look at all the different concepts in object-oriented programming, and that's all about classes and objects and the different ways that we can manipulate these. So this lecture is somewhat important because it's just the complementary to objects. However, the idea of it is not to go, you're not going to fully understand if you've not done much object-oriented programming. You're not going to come across from this lecture and this course with a full understanding of objects. Will it support you as a software engineer? Yes. Is it good to know? Yes. And it is, we are calling it a bonus topic, so do not expect any of this stuff to be in the exam or anything like that. But it is really helpful, useful information. I think it's super important to understand sort of the history of what happened with programming and how we got here. And so when I was building the lecture slides last term for the classes lecture, I thought, look, I could show a lot of code and I could do some cool stuff, but something I don't think people really appreciate is the origins of object-oriented programming. And that's what I wanted to do with this lecture. And then of course we'll do some demos and show it off in Python, how we can actually do this stuff. So with that said, welcome to sort of a bonus lecture, 9.4 Python classes in general, or the case of a misunderstood revolution. And then we'll start to talk about who this guy holding a computer is on the slides. All right. Okay, so let's go back in time a little bit to the 1950s. The first languages were imperative. What does imperative mean? This is your programming language like C. It is a sequence of commands that get executed in order, manipulating the instructions and defining instructions that the CPU runs. If you think about a CPU and how it executes commands, it is imperative. It's just, it does this, then it does this, and multiplies this, and puts it into this registry. It goes through the sequence of commands that way. And that's why the early languages were based off that model. Imperative languages meaning it's just the sequence of authoritative commands. Do X, do Y, call this function, add these two values, etc. And this worked really, really well for many years, and it still does work very, very well. And actually, there's a case for imperative style programming or procedural style programming making a bit of a renaissance. But if we go back to that point in time, there was a problem that people faced, and that is that as the scale and the scope of software projects got larger, so the entire industries like the banking industry was moving everything to software, you were getting these mammoth software systems. And what was happening is that it was getting quite hard to scale these procedural style programs. And I've spoken a bit about this with the objects lecture. So there's some code here. This is some classic C code, a procedural style C program, and you can see you've got some struct with some fields, right? Breed, name, and age, and then you've got your main function. It can create the struct, and then it goes off running the sequence of commands, and changing the values and printing it and returning or whatever. So this is an example of C and running some procedural code. Oops. Let me just see. Yeah, okay. So why are we talking about object-oriented programming? Why did it happen? What made it useful? Why did it come about and actually dominate the software engineering industry? Again, if we looked at if anyone was in yesterday's lecture, we looked at the most popular languages over time, and the top languages are object-oriented, so we can't say it's not done well. And the reason for it is again, it's the complexity. So if we think about, in 1511, you were taught over and over, don't use global variables, don't use global variables. And the reason for that is you don't want a spaghetti code situation occurring where you don't know what's modifying what. And the same sort of problem is what escalated with procedural programming. The files just got massive. There were large numbers of functions being called. It wasn't exactly clear what was executing what in what. There was just too big to manage scope. And as programs grew, so did the complexity of the programs, and so people were thinking of ways of making these programs more scalable as their complexity grew. And one of the people that was thinking about this was a guy called Alan Kay, a very influential computer scientist who actually, incidentally, wasn't a computer scientist originally. But Alan Kay is a bit of a misunderstood character with what he was originally talking about and thinking about and what originally came about from his work. Alan Kay says, this is a direct quote, "I made up the term object-oriented, and I can tell you I didn't have C++ in mind." Alan Kay said that at the Object-Oriented Programming Software Conference in 1997. So he himself has said that while he's credited as coming up with object-oriented programming, it's not quite what he had in mind. So let's think about and let's talk about what he did have in mind and what we ended up with. So this is Alan Kay talking about what he actually had in mind, right? The big idea was to use encapsulated mini computers in software, which communicated via messages rather than direct data sharing, to stop breaking down programs into separate data structures and procedures. So if we look back at this code here, this C code, Alan was making the point that it doesn't scale to have a single program with, here's a struct with a farm animal. It's got a breed, a name, and an age. And then you might have the farmer and the farm struct, and as the complexity grew, the scope of these programs just grew and grew, and you have new structs that do this and new structs that do that, and many other examples of that. So Alan was thinking, well, rather than having that be how it works, I want to break down components of code into their own separate entities. And actually, in Alan's original ideas, there was actually sort of separate machines that contained the functions and the operations for a particular entity. So in the 1970s, Alan Kay came up with a language called Smalltalk. I don't know, I doubt any of you have heard of it. It's an influential language. It's an object-oriented programming language. If anyone's read or heard of the book The Gang of Four, by The Gang of Four, it's called Object-Oriented Design Patterns or Design Patterns. I always just call it The Gang of Four. A lot of the code in that book is in Smalltalk. So Smalltalk was written by Alan Kay. And here's some example syntax of Smalltalk. And you can see it kind of sort of makes sense, but it is a different way of thinking. So you have this result variable, and you're going to assign it the response of calling the getAge requester on something called myObject. What this would basically, the way to think about this is to say there's something called myObject, so there's something that it can do, and you can ask my object for things. And this is the message that Alan was talking about. So the message here is get age. So if you look at get age, it has some code that it can execute. So it will go off and execute that code and return back a response into that result variable. So the way that Alan's thinking about this here is that you would have these different components, right? So my object might, some other thing, a farm animal, and there's a bunch of messages that object can receive and act on and knows what to return when you receive that message. So the big object-oriented concept we're talking about today is classes. So classes are how you define what objects of that type can do. So if we look at an example here, many people think about classes as being like associated with types or this sort of tree example. But I think a really good way of thinking about objects and classes is that they represent substructures of types of data. So for example, you could have a really generic object type, object class. So, in Python, for example, everything is an object. So you must have this sort of base object class. And then you've got subclasses that spawn off it. So for example, you could have a number. And then, okay, well, what type of numbers can you have? You could have, real numbers, or you could have a float, or you could, and a float would be a type of a real number, or you could have an integer that comes off another path, for example. So the way to think of the integer class is that it may be a type of number, which is, of course, a type of object, and a string could be a type of object. Or you could have something completely different, like a window, which is a different type of object. And then when you actually create that object, you take a class and you actually create an object from it, this is when we end up with the object. And there was a reason why I put a turtle here, but now I've forgotten. So we've spoken about objects a little bit, but the big difference between objects and something like structs in C, for example, is that objects know things, which is normal, we've seen that, but they can also do things. And this is as close as we got to Alan Kay's idea of it being a message-based system. So we'll jump into demos in a second. I know that was a very abstract talk. Now, Stephen's asked a really good question. Isn't this similar to function calls, right? So Stephen's talking about this here. So we have this my object, and it's got a message called get age. The difference is, right, in the original idea, Stephen, is that my object is a black box. You don't know everything that it does, how it works, or what it can do. You just know it's publicly accessible sort of messages. In fact, the closest way to reason about this stuff is to think of it more like HTTP endpoints that you make in Flask. That's kind of sort of what Alan was thinking about, but in a sort of microarchitecture sort of way. So the idea is that, you've got this endpoint and there's a series of endpoints that you can hit. And as long as you know how to hit it, you might know, you'll get some data back, and how that data was generated, you have no idea what the backend did. And this is sort of similar to what Alan was imagining here, and maybe sort of not what got implemented. Because I think what the big difference is, what Alan was actually imagining was that these different components could actually be on different servers. So it was really something like HTTP that he was thinking about. Okay, that's all very theoretical. So let's actually look at what, if we jump 10, 20, 30 years later, we have an object-oriented language called Python, and Python lets us create classes and create objects from those classes. So to take a step back, let's look at some C code here. How would you create something like farm animals in C? So we have this idea that we want these structs or some records that contain some information all related to a farm animal, right? So this animal could have an age, a breed, a name, a sound, whatever. These are just strings or char arrays. Then in main, I can say that I want to create a variable of this type, struct, farm animal. So in this case, I'm creating two variables. And I can assign or set up the breed of the dog, the name of the animal, the sound it makes when it barks, and the age of it, or whatever. And then I can print out those properties here. So we are able to encapsulate, even in something like C, like properties into some sort of custom data type of struct. But what's important with this, and we'll talk about this in when we look at the Python examples, is that structs only know things. They only know, what do I mean by know things? It has data. It knows its breed, it knows its name, it knows its sound, it knows its age, but that's it. It can't do anything, right? If we want to do something, we have to basically write a function or write some code that reads those values and then does something. And this is the big difference between procedural programming and something like classes. So what a class lets you do is define, just like we defined a struct in C, define a class in Python. And this is the syntax for it. You type class and then you give it the name of the class. And then you say everything that follows in this block belongs to the animal class. Okay, so let's look at this, right? So let's not look at that. Let's look at, I guess I could just do name equals spot, for example. This animal has a name now, a string called name. Okay, I don't want to jump too far ahead, so let me just not worry about this. This animal has basically a bunch of these functions, this class, associated with that class. And when we execute these functions, something happens, right? The function gets executed, and these functions are associated with the class. So if we look back at the structs example from C, what is an object? What is a class? It's basically, one way to think about it is a dictionary that can also contain functions that can get executed. This is something we can't do in C, but we can in Python or with object-oriented languages. And why that's important is that we can now sort of encapsulate not only information, so like properties, which we do here, and I'll talk about in a second, but also functionality associated with a class. So here we have the initializer in Python. Basically every class needs to have, or should have, can have a function called __init__. And basically what we do here is that we say when we create an object of type animal, I want to give it a name and an age. These are the things that it knows, its own properties. And we use that by calling the animal constructor, right? So we say animal equals a new animal, and its name is Spot, right? Its name is Spot, and its age is 10. Now the self property is always the first property when we define, or the argument when we define any methods associated with an object, and it's how it knows which object, which animal it's referring to. So basically you can think about this as though it's passing in animal into the self parameter. Now what does this actually mean? Let's just comment this out for a second and run this. Python, it's called classes1. That should be fine. Okay, nothing happens, that makes sense. Why don't we just print out here animal, right, this first animal. And we'll see that this animal object got printed. So what do we have here? We have an actual object. And that object contains a bunch of things. And the things it contains were defined in the class. So what this means is that we can actually see, well, what are the things that the object knows? Well, it knows this name and this age, because these are properties just stored on the self object, which is, for example, animal. So I can print out animal.name. And in this case, it's going to be Spot. I can print out animal dot age, because that's also something that the animal knows, and I would get out that 10. That's sort of nothing different from a struct in C. The big difference is that I can actually define functions or functionality in these classes, and this is sort of what Alan's talking about, where you can ask it to do something by asking it for a message. So you can see this cry method here. And when we say method, a method is just a function on an object. So cry says the animal named self.name makes a loud cry. So we can actually do that. So we can call cry. Now cry is a function because it's a method, so we can give it the parameters there to execute it. And then we'll find out that when we actually call that, oh no, we're not printing it, right? The animal named Spot makes a loud cry. So we've actually encapsulated functionality into the animal object or via the animal class. Whereas if we were to look at this C code, we would need to make like a function here that like, you know, returned void that was like cry. It took in a bunch of things, and you need to know what type of animal is it and all of that stuff. Whereas with classes, we can say, well, then if you've got an animal, animals know how to cry. What do I do when you call cry? You just run the code here. This could be, you know, multiple lines and things like that. And because we're creating these encapsulations, that means we're able to create multiple animals. So here we go. Animal 2 is a different animal with the name Gary and the age of 5. So I can, you know, make animal 1 cry, and then I can also make animal 2 cry. When we say cry, I don't mean like cry. I mean like make its noise, right? I'm not an animal abuser. And this made Gary, whatever animal Gary is, make some noise. And we can do a bunch of other things like write getters and setters and things like that. But again, we're not going to go too far into that depth. Okay, now we're going to talk about one more really powerful idea behind object-oriented programming, and that is inheritance. So we have this idea of animals, right? Animals have a name, an age, so they know things, and they can do things. Like, for example, now I feel bad for calling it cry. You know, maybe I can make it like make noise. Yeah, it's like a Tamagotchi. Yeah, exactly. Exactly. So, but we need to really think carefully here about what we're trying to do. So we've got this, you know, idea we're building some sort of farm simulator. There's a bunch of animals walking around. And no matter if you have a dog, a cat, a horse, there is some qualities, information, and things that these animals can do that is common to all of the different types of animals. And so this base behavior belongs in the base class. So for example, every animal, no matter what thing it is, it's got a name and it's got an age. So what we can actually say here is that all animals will have a name and age, and all animals can have make a noise. Now we don't know what type of noise it's going to make, right? So we don't, you know, an animal doesn't know if it's a bark or a meow or whatever it is. It just knows that all animals can make some noise, you know, probably. But then what we can do is come along and say, well, that's what an animal is, but I know I've got dogs on my farm. And dogs are like animals, so they inherit from animals. And this is all built into object-oriented programming when we create classes. So these dogs can do things that animals do. All dogs are animals, but not all animals are dogs. So what we can say here is that all dogs, you know, have a name, have an age, but they also have a dog breed, okay? And so that's specific to dogs. And so we can even override these make noise functions. So for example, if an animal makes a noise, you just say, well, it just makes a loud noise. But if a dog makes a noise, it's making a woof. And so what we've done here is created two classes. We have the same animal class that we had earlier, and we have this new dog class, which using some of the Python syntax, and the syntax changes depending on the language you're in. But we can inherit from the animal class and actually do some extra specific things that only a dog can do. And so if we run this code, we can actually see that, so what do? We made an animal, we made a dog. An animal makes a noise which calls the, let me just run that again, which calls, its make noise function or method. And then when we ask the dog to make a noise, the dog actually is barking, because when you ask a dog to make noise, you don't run the animal make noise method, you run the dog make noise method, which prints out a woof, right? So Stephen's asked, can we write logic in these classes? And that's the exact sort of point I'm trying to make, right? That's exactly what we're trying to do. Let's sort of build on this a little bit. So let's say we've got all animals. You can define a method called getAge. Okay? So you can get the age of an animal. And by default, it's just going to return self.age. Because self.age is assigned when we create an animal, and we have to give it an integer. So all animals will have this getAge. So if we ask, if we get the age of the animal and we get the age of the dog, what do we expect to see when we run this? What we expect to see is the age of 8 get printed out and the age of 4 get printed out. And that's exactly what we see. But we can actually, put logic into these class definitions so that when we have these objects, they do different things. Now, we know that, so this getAge functionality, we didn't have it in the dog class, right? It's coming from this base animal class. But maybe you can get, you can override what a dog does when you get its age. And we can actually put some custom logic in here. So we can say something like, so the dog age is equal to self.age. If dog age is greater than let's say 10, we can say, well, let's return the dog's age. Let's return actually an F string. I'll say the dog is the dog age, which is actually quite old for a dog. And you can say, else you could return the dog as dog age, which is, well, we don't have to say that at all. You can say the dog is however old it is. But if the age is greater than 10, we are doing a bit of extra things here. But the point I'm trying to convey is that this functionality is only specific, some specific logic only for the dog object. And then Stephen's asked another great example here with the make noise, right? So we have this dog and we have this animal. Well, we can write a class for a cat. So a cat is also a type of animal, right? It's not a type of dog, it's a type of animal. And it can, let's just copy this in. It doesn't have a dog breed. So what this is doing is saying, well, here's the initializer for a cat, and basically what I'm saying is that it's also that you have to call the initializer for an animal, because when you initialize the cat, you're also initializing an animal. So that's what's happening here. And then we can also have, though, this make noise method. Now, an animal makes a noise, we just said it makes a loud noise. When a dog makes a noise, it woofs. But when a cat makes a noise, what's it going to do? You're going to print out a meow, right? But the really important thing here, and then we can come across, come down here, make a cat. Does someone have a cat in chat and want to give me a name for their cat? Oh, Joey's pretty cute. We're not calling the cat dog, just to make it too confusing. Okay, so we've got this 3-year-old cat called Joey, and if I call cat dot, what do we call it? Make noise, yeah. We should see that meow get printed out. Cool. I know we're really rushing through this. I'm completely fine if you don't fully understand it. I just want some of the ideas to be exposed to you, right? So that, again, this is not going to be on the iteration or the exam or anything like that. It's just to sort of show some stuff. But I want to show you one more cool thing before we wrap up today that we can do with these objects. So we've got cats and dogs, and all cats and dogs are animals, and all animals know how to make a noise. So what this means that we can do is actually make our farm be a list of animals, and then we can say farm.append the dog, and then farm.append the cat. So if I print farm, let's get rid of that. And actually we can make 2 dogs here, you know. What was another animal here? Kit, cat, it's pretty cute. Make it a cavoodle. You know, we can even add, oh, did I delete the... What we have here is a list of, oh, it's a C, that's embarrassing. I'm not a dog person, if you can't tell. So we have a list of these objects, a dog, and a cat. But the really interesting thing to think about is that these are all animals, right? A dog is an animal, a cat is an animal. And so what that means is that we can actually go for animal in, also for A in farm, A dot, actually I don't know if this will work, but let's see. A dot make noise, I think that's fine. Yeah, awesome. Let's just get rid of this. And what we find here is that even though we've got dogs here, we've got cats here, and make noise is a function that exists on dogs and cats. Because that function make noise exists on the base class of animal, we can actually iterate through all of these objects and ask it to make noise, which does different things depending on what the animal is, because they've all inherited from the base animal class, which is really cool. And so you can start to see here how we can make these scalable software solutions. Like, so someone made a joke about, you know, a giraffe enters the chat, but there's you know, this is how easy it is to do this now. So I can say, well, I don't know why I just changed a thing that I was meant to change. Say spell giraffe. A giraffe is an animal. It's got a name and an age. I have no idea what noise a giraffe makes. Can someone Google that for me real quick? I mean, it'd probably be quicker if I just Google it. But so we change this to whatever noise a giraffe makes, and then down here we could make it, you know, make a giraffe. And again, I don't know what you'd call a giraffe. Call it long neck. 5-year-old little long neck. Append it. Is it grr? Is that really what was? It's so menacing. Actually, giraffes are quite menacing in general. Have you ever seen like giraffes fighting? They're nuts. Anyway. And you know, without changing any code down here, we get our giraffe that goes like grr and makes this menacing sound. So our farm really is a list of animals. And even though these animals are different classes, different objects that can do some slightly different things, if there's common behavior that exists in the animal class. So for example, you could have a function called move, or walk, then you can say, you do something. Oh, this keyboard sucks. Do something, and you can, we can just log it and say like, move forward. We can also, did I just call it move? No, I called it walk. Walk's probably not very good because not all animals walk. So we'll call it move. We can run this, and so now I've asked all my animals to do something, to run some logic in them. Hemi asks, so for importing a file, can it seem like importing a class? I don't quite know what you mean, but so I guess what you're saying is like, how do you import these things around? So a really common thing is that, if you've got like an animal class, the definition for it would exist in the animal Python file, and then you would just import the animal Python file just as you import any file in Python, and then you would be able to create your own animal objects, right? And then you could put like giraffe in its own file, you could put it all in a folder, you can do sort of whatever you want in Python. It's quite nice. So this is how sort of behind the scenes, right? When you use Python and you're using objects in Python, there's basically always a class somewhere that defines what that object knows and what that object can do. So a really classic example is well, not classic, but let's look at, where's my browser gone? Whatever. List class source code in Python. I'm just trying to find. Okay, here we go. So, okay, well this is, so if you, well, this is a bad example actually. Yeah, because Python itself is written in C, so you can't actually, it's not easy to see it. But my point is that any of these built-in objects in Python do have an implementation somewhere that defines what that class is. And then you can go and look at it. So if you're using, for example, any module that you import, somewhere in that code base there is a class that defines what the object knows and what the object can do. So yeah, that's all I wanted to sort of talk about with the classes stuff. I know we really sort of powered through a lot of sort of complications here, but what you can start to think about before you go off and do some more in-depth object-oriented programming is that object-oriented programming was a solution to certain problems where scalability wasn't really working in large procedural programming. So the idea behind it is to come up with a way to create classifications. I mean, that's what class actually, I think, stands for. These classifications of structures, of entities, where there's like functionality. So for example, a graphics window is still an object, just like a string is. And there's some common things that even those two different entities can do. So it's a classification of information and logic, and functionality. And at a high level, that's all that's really happening. And if you create a number, a number knows some certain things, like its value, and can do certain things, like turn itself into a string, for example. But that's a really high level discussion on classes. It's kind of impossible to do a lecture like this in 30 minutes or an hour. It is an entire course, and I hope some of you who are interested will go on to take the object-oriented programming course at CEC, and you'll get really in depth into this stuff and how it works under the hood. But other than that, I think I've spoken at you all enough. Thank you all so much for coming to today's lecture. Do you have any final questions before we head off? 2511. Yeah, you're right, Stephen. Sorry. You're right. Not 1521. Cool. I've got to say, have a happy, whether or not you're celebrating Easter, but enjoy the public holiday. You can celebrate that at the least. You're all amazing, hardworking. One more iteration to go. Next week, we'll have a quick chat about what to expect in the exam as well. But good luck with iteration 3. What I'm seeing so far is looking really promising, and I hope you're really enjoying some of the cool stuff that happens in iteration 3. I think iteration 3, I don't know if you guys are finding this too, but with the deployment and the image uploading and that there's some cool stuff in it that's exposing you to some new ideas. So hopefully you're really enjoying it. I know some of you are probably over it too, but I promise one day you'll look back at 1531, maybe when you go out into industry for the first time, and even though we push you, I think you'll appreciate that we expose you to so many of these things like Git and collaboration and Flask and things like that at such an early stage. So have a happy long weekend. Work hard, but don't work too hard. I'll see you all next week. Can you believe it? The final week lectures next week. It's incredibly sad that it's over. But I'll see you all next week. Have a happy Easter.